Hello, I'm Kristian Hammond. We're coming to you from Northwestern University's Center for Advancing Safety of Machine Intelligence, or CASMI. As you might expect, CASMI is focused on safety. There are a lot of issues we have to address when we consider safety in AI. We want to talk a bit right now about how to structure our thinking as we look at the issue of safety. Much of the current work in responsible AI falls under a rough umbrella of ethics and can be broken down into questions of bias and fairness, accountability and trustworthiness, how to build transparency and explainability into our systems, as well as how to maintain privacy while building large data-driven models. And when all is said and done, what is the future of work in the face of more and more intelligent systems? All of these issues are important to our work at CASMI, and we back efforts in these areas. But CASMI's focus is on what we see as a more fundamental problem. How do we make AI safe? Not just in theory, but in practice. How do we operationalize safety? It's important to note that when we talk about safety, we have to talk about harm. Safety and harm are two sides of the same coin. When we say you are safe, we are saying that you are safe from harm. At CASMI, we think a great deal about harm. In particular, we think about the different ways in which systems can harm us and the sources of that harm. For example, a system's bias might come from the core data it was trained on, decisions about features used in the training, the ways in which users interact with the model, or even the way in which the system was deployed. So when you want to uncover the causes of harm, where do you look? How do you build a framework to explore the harms caused by AI systems? For CASMI, the answer was to reach out. Over the course of a year, we emailed, called, and Zoomed dozens of researchers and practitioners in computer science, psychology, anthropology, philosophy, human-computer interaction, and organizational design. We used those lessons to hold a series of workshops designed to tease out a core framework to guide how we should move forward. The result of this was a framework. The framework has two major components. First, we need to gather facts about how we are building systems, looking at the issues of data, algorithms, interaction, and deployment. Then, we can evaluate those systems based on those facts, the harms that they gave rise to, and the collection of goals and values that surround them. This division between fact and evaluation is crucial to how we think about safety. The argument is simple. It's not possible to have a real conversation about issues of evaluation, ethics, or responsibility without access to the facts about the systems we are discussing. It's like the television show Law and Order. Every episode begins by telling you there are those who investigate and those who prosecute. Establishing the facts gets us to the truth. Evaluation of that truth gives us our response. The focus on different steps in the development process allows us to deconstruct or unpack complex problems into more manageable issues. This then allows us to identify specific failure points that can be addressed. Our starting point is the data and how errors impact possible harms. Here we need to consider what can go wrong while we're gathering data, merging data sets together, enhancing it, or selecting which aspects of data sets should be kept or removed. The issues are a combination of technical and sociological, as both humans and machines can introduce error. Next, there are the issues at the algorithmic level, ranging from training and testing techniques to our choice of learning targets and evaluation functions. Here again, there are sociological as well as technical questions that must be asked. Engineers are often unaware of how their work will be used in larger systems, but they might want to focus on safety, but lack the context and information that will help them do so. Then we need to consider how people are going to interact with these systems. An unbiased model can still cause harm if it's not designed with human cognitive skills and deficits in mind. A system that provides answers that are then evaluated by a user will perform differently than one that takes a user's suggestions and provides commentary. Even if the underlying models are identical, our tendency to stick with the norm, that is what has been suggested, gets in the way of modifying the results of a system. And then there's the question of how these systems are deployed and what users are told about how they work and perform. Users who see systems as tools rather than advisors have different models of them and take different approaches to using them. This then brings us to evaluation. How do we look at these facts and balance the trade-offs between our goals, values, and the harms we have surfaced. From our perspective, evaluation is the most fraught of these issues, but one where we can make the discussion stronger because it is based on a foundation of fact. This framework is a powerful tool in that it provides the guidance we need to develop a research roadmap. It provides us with a structure that points us to the research required to gather the information we need. And while it's a living document, it provides a starting point that directs us to where to look as we explore the possible harms caused by AI. Because we can't make AI safe unless we understand when and where it is causing harm. Thanks for joining us. And please, stay safe.